Hello everyone, in this lecture you will cover data loading in PyTorch. Data loading is one of the first steps in building a deep learning pipeline or training a model. This task becomes more challenging when complexity of the data increases. So now you will learn about the dataset and data loader class in PyTorch that helps you to load and iterate over elements in a dataset. So loading and converting data into formats that are ready for training can often ends up being one of the areas in data science that sucks up far too much of our time. PyTorch has developed standard conventions of interacting with data that makes it fairly consistent to work with, whether you are working with images, text, audio, or video. So there are two main conventions of interacting with data, which are dataset and data loaders. So what is dataset class in Python? A dataset is a Python class that allows you to get at the data we are supplying to the neural network or the deep learning network. And on the other hand, what is data loader? A data loader is what feeds data from the dataset into the network. This can contain information such as how many worker processes are feeding data into the network or how many images you are passing to the network at once. Now let's deep dive into the dataset and data loader class in PyTorch. So let's first start with the dataset class in PyTorch. So here is the code of the dataset class in PyTorch. Dataset class in PyTorch help you to get at the data we are supplying to the network. This class is available as dataset in the torch.utils.data module. Dataset class consists of two main methods, that is getItem and length. You will see the detail of these methods later. And also we will implement these methods when we will implement the customized dataset class for our dataset. So every dataset, no matter whether it includes images, audio, text, video, 3D landscapes, stock market information or whatever, can interact with PyTorch if it satisfies this abstract Python class. So this Python class can be customized according to the requirement, and we will customize this dataset class for our dataset. Now let's have a look at the dataset class functions in PyTorch. Previously we have seen the dataset class consists of two methods, the getItem and length. The getItem function loads and returns a sample from the dataset at a given index. Based on the index, it identifies the image's location, converts that to a tensor, retrieves that corresponding label from data, calls the transform function on them if applicable, and returns the tensor image and corresponding label in a tuple. And the length function returns the number of sample in our dataset. Now let's move ahead to implement the custom dataset so that we can load the data into the network. So before we move ahead to implement the customized dataset class, let's see how we can access the data from Google Drive. So previously we have seen the tray dataset. I have placed the tray dataset on my Google Drive. Here you can see the folders of the tray dataset. So here you can see the 6 folders. For example, X test, and also you can see the Y test. X test folder contains the original images, and the Y test folder is basically contains the segmentation mask or the label corresponding to the original images. Similarly, you can see the X train and Y train folder and X validation and Y validation folders. So I have placed the dataset at this location, my drive, Google Notebooks, and then tray dataset. So here you can see the few X test images and Y test images. Here you can see the my drive, Colab notebooks, and tray dataset. And in tray dataset we have opened the X test folder. So X test folder is basically contains the original images, and on the other side you can see we have opened the Y test folder. And here you can see the segmentation mask or the labels corresponding to the original images. For example, this is image 1001A01 and its corresponding segmentation mask is here. You can see the same image name or ID that correspond to the original image. Because for experimental and evaluation purpose, we need the segmentation mask corresponding to each image. So now you can see the code to access the data from Google Drive. So first of all, data variable consists of the path where we have put the dataset into the Google Drive. So this is the path where we have put the dataset in the Google Drive. So using this path, now we will access the each folder or the each directory within the dataset. So we have used the os.path.join library that will join this path and the directory. So xtrain directory basically consists of the full path of the xtrain folder, and similarly ytrain directory and xtrain and xvalidation directory and yvalidation directory, and finally the test dataset x test directory that consists of the original images and y test directory that consists of the segmentation mask. So here we have the paths of the 6 folders inside our Google Drive. Now let's switch to the Google Drive so that we can access the data from Google Drive. So here we go. Here you can see we have already mounted the Google Drive from where we will access the data. Then first of all we will import some libraries like import OS, and then os.environment CUDA visible device is equal to 0. That basically enable the GPU of the Colab. Then we have imported the numpy's cv2 and matplotlib so that we can plot the images or the graphs. So here is the code to access the data from the Google Drive. So first let's run this code to import the libraries. Then let's run this to access the data from the Google Drive. So let's run it. So here we go. So let's count the number of images in each directory. So here is the code where we can use the os.walk that will iterate over this directory via test directory, and it will get the paths, directories, and also the number of files or images. Then we have counted the length of the number of images or the files in the file count. Finally we have printed this. So let's run this, and here you can see we have 20 images in y test, and similarly we have the same images in xtest, because xtest contains the original images and ytest contains the corresponding mask against the original images. Similarly, for example, we want to see the training images. Let's copy the xtrain directory and paste over here. So let's run it, and here you can see the training images. It's 1217 images in the training folder. So similarly ytrain folder also contain the same number of images. For example, let's try the ytrain directory and put it over here, and then let's run it. So you will see the same number of images. So now let's check the validation images, how many we have the validation images. So just copy and paste and run. So in validation images we have the 12 validation images. So we have accessed the data from the Google Drive over here. So now we will implement the customized dataset class for this dataset so that we can feed to the network. Now let's move forward to implement the customized dataset class. So here is the code for our customized dataset class. So class dataset and then base dataset, where base dataset instance is representing the abstract dataset class. Then first of all you can see the init to initialize the class. As you know that init is a reserved method in Python classes. It is called as a constructor in object-oriented terminology. This method is called when an object is created from a class and it allows the class to initialize the attributes of the class. Then in the arguments you can see the first argument is self. The word self is used to represent the instance of a class. By using the self keyword we access the attributes and methods of the class in Python. The second parameter is image directory. That is basically the original image directory, for example the training images, and then the mask directory, that is basically representing the mask corresponding to the original images, and then number of classes, and then augmentation if applied, and then pre-processing if applied. So next you will get the images and the mask IDs. For example, in this line of code, it will get the images IDs. The original images IDs are represented by X and the mask IDs are represented by Y. Here you can see we have sorted the IDs of the original image directories. And next in the IDs Y, we have also sorted the IDs of the mask corresponding to the original images, so that we can access the corresponding images IDs and mask IDs correctly and they do not be mixed up. For example, if we print the self.ids x, we will get the IDs or the name of the images. For example, the first image is 1001a01.jpg. So this is the full name of the image that is placed on the Google Drive. And then this is the second image, and similarly if we print the self.ids y, then we will get the corresponding IDs of the mask of this original image over here. And next we will get the images and mask full paths. So here you can see self.images full paths fps is basically representing the full paths. So here we have joined the images directory path and image ID. For example, here you can see the first image and the content drive, my drive, collab, notebooks, trade dataset, xtest dataset. This is basically representing the image dir, and here you can see the 1001a01.jpg. This is basically stored in image ID. So here we are getting the full path against each image so that we can access the image later, or similarly we are getting the masked full paths. And next, self.class values will contain the class's numerical values. For example, in this code of line, we will convert the classes string names to classes numeric values. For example, if there are 10 classes like pizza, pasta, etc. For example, if pizza is at location 1 in the list or the array, then its value will be converted to like 0, and similarly 0, 1, 2, 3. And then if we apply the augmentation, then self.augmentation is equal to augmentation that we have passed over here in the parameters. And then if we have applied the pre-processing, then we will also declare a variable self.preprocessing. But in our case, we will apply the augmentation and pre-processing, and we will see it later. But for the time being, you remember that we have used this in our customized dataset to augment the data. So let's move to the next slide. So here you can see we have defined the get item method. In get item method, we will basically read the data image by image. For example, here you can see image is equal to cv2.imageRead, and then we have put the self.images fps I. Basically this is representing, for example, the image 1 path. Images fps I is representing the image 1. For example, if I is 0, for example, for the first time it will read the image 1 into image that will be basically the original image. Then this image will be converted into bgr to rgb, and then you will read the mask corresponding to the original image. So here you can see self.mask fps I. So now in this code, image 1 we have accessed in the image variable that is now stored in the image, and corresponding mask is stored in the mask variable over here. So similarly we read each image and mask one by one. Then if you want to extract a certain classes from the mask, for example bread, pizza, pasta, then here is the code mask is equal to v for v in self.class values. You remember we have defined the self.class values where we have converted the class names into numeric values. Then here you will apply the augmentation on the image and the masks you have read, and then you will apply this pre-processing to the image and the mask bots. So remember we have the augmentation and the pre-processing in our customized dataset. So if we implement the augmentation and pre-processing, then it will be applied in the customized dataset. We will see it later. And finally this method will return the original image and its corresponding mask with the augmentation and with the pre-processing if we applied. So in this method, first we have read the original image and its corresponding mask, and then if there is a augmentation and pre-processing is defined, it will be applied, otherwise not, and it will return the image and mask. And also you know that we have one more method to get the length of the dataset. So that method we will see in the Google Colab. So let's switch to the Google Colab to run this code and to read the dataset. So previously we have seen how to access the data from the Google Drive. Now you will move forward to load and to read that data. So for that you will implement the customized dataset class. So first of all, let's see the classes. Let's see the number of classes we have in our tray dataset that we have placed on the Google Drive. So here you can see the classes in the tray food dataset: background, tray, cutlery, form, straw, meatball, tomato, pumpkin, bread, margarine, milk, juice, orange juice, and water. So this dataset basically consists of 43 classes in total. So let's run this. And next we need torch.utils.data import dataset, that is the abstract class library. So let's run it. So here you can see we give this library name as base dataset that we have passed to our customized dataset class. So here is our customized class that we have seen previously in detail. So here you can see the init that we use to initialize some arguments, and here is the same code. So here is the get item method that we have already seen to read the data, and here you can see the length method that basically will return the length of the dataset or the total number of images. So let's run the code for our customized dataset class to load the data. Then we have defined another method, that is visualize. We have defined visualize the image and mask. Here you can see we have passed the image and mask, and then we have plotted. So let's run it. So this is the code that we will use to visualize few images of the dataset. So here you can see we have used the for loop label in classes, and then we have defined a dataset. Here we have used the customized dataset class. Here you can see, and we pass the test images, the original images, and the corresponding masks, and then we pass the classes, and we will get the image number 2 from this dataset that we have defined over here. We will get the image and its corresponding mask, and then this image and mask we will pass to the visualize method that we have just defined above, and this will show us the original image and its corresponding mask with the individual classes. So let's run this and see the output. So here we go. So here we have the result after the execution. So here you can see the background, and then you can see the tray, and then you can see the cutlery. We have the cutlery in this image. We don't have the farm, we don't have the straw in the image, we don't have the meatball, we don't have the beef. We have the roast lamb. Here you can see in the original image, this is the roast lamb. And there are many classes we don't have in this single image because there are 43 classes. We don't have the leaf, we don't have the tomato, and also here we are scrolling down, we don't have the baked fish. We have the gravy. Here you can see the gravy. We have also the zucchini. Here you can see the zucchini in the original image. We don't have the carrot, we don't have the broccoli. We have the pumpkin. Here you can see the pumpkin in the original image. And we don't have sandwich, we don't have side salad. So we have the jacket potato in the original image, and also we don't have the cream potato, we don't have the bread, margarine, we have the soup. Here you can see this is the soup. We don't have apple, and here we go. And we also have the custard. Here you can see this is the custard. And we don't have the juice and apple juice, and we have the orange juice. This is the orange juice you can see. And we don't have the water. So here you can see we have explored the data. So here you can see we have seen the original image and its corresponding classes in the masks. So in this lecture we have accessed the data from the Google Drive, and then we have defined a customized dataset class to read that dataset, and then we have explored the dataset. So in the next lecture we will implement the augmentation and pre-processing. Then we will go with the data loaders, because we will apply the augmentation and pre-processing to our training dataset, and for the validation and for the testing dataset we will use the pre-processing. See you in the next lecture.